Okay. Hi, good morning, everybody. Welcome. This is session IOT206, Computing at the Edge with AWS IoT Greengrass. My name is Scott Allison. I'm a Senior Technical Product Manager on the Greengrass team. And with me is Tatiana Cook, another Senior Technical Product Manager on the Greengrass team. So we'll be covering kind of at a broad, high level edge computing and how you can do that using AWS IoT Greengrass. Just as kind of a side note, I apologize if my voice is a little bit hoarse this morning. It is definitely not because I went to replay last night, but I heard it was very nice, and I hope you all had a nice time. So let's go ahead and get started. We'll begin by giving an overview of edge compute and AWS IoT Greengrass, and then we'll get into some of the new features that we're releasing with 1.7 around simplified deployments, enhanced security, and greater flexibility. So to begin, why do we need edge compute? Well, we talk about it in terms of what we call the three laws. There's the law of physics. The speed of light only goes so fast, and response time and latency are very important for a lot of mission-critical applications at the edge. Self-driving cars, manufacturing, automation and monitoring, and issue remediation. So in industrial environments or oil and gas environments, the time between detecting an anomaly and equipment failure could be seconds. And while getting to the cloud is generally pretty fast, you want to have immediate response on site without having to make a round trip across the internet. So we also talk about the law of economics. There's a lot of data that you can collect from IoT sensors and devices, gigabytes, petabytes even. And moving that stuff to the cloud can be expensive. And so you might want to do some processing at the edge, gather things up, summarize them, filter them, or just generate KPIs to send back to the cloud to minimize the amount you spend transiting data to and from the edge. And then there are regulatory requirements, the law of the land. We talk about things like HIPAA or FERPA or GDPR if you're in the EU, and there may be compelling legal reasons that you want to keep the data on site without transiting it to the cloud. So, knowing those things, we want to help you enable those edge scenarios to help you get around these three things. So what's a common edge scenario look like? Well, it's pretty straightforward, actually. You can collect some data from on-premises devices at the edge, temperature sensors or automated devices or home security appliances. You can cache and analyze the data at the edge. So for example, if you're monitoring a temperature sensor for days at a time, and you only really care when the temperature goes above or below a certain point, you can simply write some logic at the edge to analyze the data and only send data up when it is over or under a certain value. And then finally, once you have that data, you can perform actions, transfer data to cloud services, connect to on-premises or in-cloud applications, and perform actions. So a good example of that might be, I'm collecting that information from the temperature sensors, and when it goes above or below a certain threshold, I want to be notified of that. So I could connect to SNS using a device at the edge and send a notification via an SNS topic so I'm alerted when temperatures go above or below a certain threshold. So that's an edge scenario. And when we talk about the edge, you're probably thinking, yeah, that's great. Edge sounds really nice, but isn't that just on-premises computing? Decentralized versus centralized computing. And that's true. And the pendulum kind of swings back and forth every 10 years. But it doesn't necessarily have to be all or nothing. You don't have to always be on-premises. You don't always have to be in the cloud. You can have the best of both worlds. And so we try to help that be a possibility with AWS IoT Core. You can manage IoT devices from the cloud and transit data from IoT devices into other AWS services for processing in the cloud. But again, we're talking about the edge. So what if you don't necessarily want to send everything to the core all the time, or you have issues, intermittent connectivity, or regulatory requirements that we talked about before, things like that? Well, let's dive a little bit deeper, right? So we'll talk about the edge scenarios here. If you only want to perform that analysis and data caching at the edge, then you might build yourself a gateway. So this cloud with a door in the middle here is a device that could act as a gateway that transits data from gateways on premises to AWS services. So you might be using SageMaker to generate machine learning models, and you might be refining that with data that you collect at the edge, or you might be using SageMaker models pulled down to the edge to perform image identification or video analysis. You might be using IoT Core for analytics or transiting data to other AWS services. You might be using AWS Device Defender to ensure that your devices are properly secured, monitor those things over time. And you might also be using AWS Secrets Manager to manage the secrets that connect you to your on-premises and third-party applications. So the way that we enable that for you is with AWS IoT Greengrass. It's an extension of the AWS cloud to the edge for IoT applications. And we provide a lot of things with the Greengrass platform. So local messages and triggers, we provide a local MQTT broker that can actually manage MQTT messages from local devices and into the cloud. Local actions, we talked about that a little bit. It's an extension of the Lambda runtime to the edge so that you can write applications in Lambda, store them in the cloud, and deploy them to edge devices in a format that you're already familiar with. Data and state sync, you can manage IoT device shadows locally from on the Greengrass Core device. Security, we allow you to encrypt things with hardware secure elements and ensure that the data you store on the edge devices is secured with AWS-grade security. Local resource access, if you have cameras or temperature sensors, industrial devices, we allow you to manage and access those devices from a Greengrass Core for data collection and management. And machine learning inference, I mentioned this one a little bit before as well. You can pull SageMaker models down onto the devices and perform ML inference at the edge without having to go back to the cloud. We just announced recently support for SageMaker Neo. You may have seen that as well. And then AWS Greengrass Connectors. These are prepackaged pieces of functionality for common edge use cases that you can install without writing code. Over-the-air updates, we allow you to keep your device up to date and current. And the secure credential storage, if you're using AWS Secrets Manager, it allows you to extend AWS Secrets Manager to the edge for the secure storage and encryption in transit and at rest of secrets. So that's AWS Greengrass at a high level. So why did we build it? Well, it's going to be very familiar as I talk through these points because we're talking about local code execution. We want you to be able to perform actions at the edge rapidly to help you with those laws of physics. So you can execute Lambda at the edge and perform those actions locally. Secure connectivity, we just mentioned this as well. We want you to be able to trust that your data is encrypted and stored with AWS standard security at the edge. ML inference, like I said, we want you to be able to pull non-computationally intensive ML inference tasks down to the edge so that you can do the work without having to go back to the cloud. And local actions and resources, so you can access the file system or cameras to build applications that access the hardware you have available on site. So, local actions. So Greengrass, as I said before, extends Lambda to the edge so that you can build a Lambda, store it in AWS Lambda, and deploy it to the edge by attaching it to a Greengrass group. They run Python 2.7, Node.js, or Java, and we're looking to expand those runtimes in 2019. And you can invoke Lambda functions with messaging and shadow updates. And again, we've given some examples of what you might use that for at the edge, but you can perform actions that are triggered by certain scenarios that might occur at the edge. We'll talk about local resource access now. Like I said, you can access local resources on device, the file system, the cameras. You can use things like GPIO to communicate with other devices. And then you can use the local file system to access any data that you might want to store at the edge. And in hardware or in machine learning scenarios, you can access GPUs for hardware acceleration and machine learning tasks. So to make all of these things easier, we've released Greengrass version 1.7. And along the way, when we talk about what you do at the edge, we're talking about building Lambdas, securing your environment, making sure that it deploys correctly, and building an application that's flexible enough to do the things that you need to do at the edge. And with that in mind, we're simplifying deployments with Greengrass Connectors, which I mentioned before, and we'll get into in a little more detail in a second. Enhanced security, AWS IoT Greengrass Secrets Manager, which extends the cloud version of AWS Secrets Manager to the edge. AWS IoT Greengrass hardware security integration, which allows hardware secure elements to be used on Greengrass devices. And greater flexibility. So we're talking about per Lambda isolation and permission configurations. My colleague Tatiana will talk about that as well. So there's some things that we won't cover in the session, but I want to mention here that are part of 1.7. We've added the ability to perform bulk deployments via API. So if you have multiple Greengrass groups, you can perform deployments to multiple of them at once with a single API call. ALPN and proxy support, if you have limited network availability or you have IT requirements that require you to operate behind a firewall or use a proxy, we have support for that in Greengrass now. And ML inference, as I mentioned before, we've added support for SageMaker Neo and the ML inference connectors available in Greengrass as well. So now I've kind of given the little overview of 1.7. Let's talk about the simplified deployments piece. AWS IoT Greengrass Connectors. What are they? So as I mentioned before, when we talked to customers, what we heard was that there were a lot of common use cases that people did over and over again, communicating to cloud services for building things like notification through SNS, like I mentioned earlier, or aggregating data, or connecting to on-premises applications, or even talking to things that use specific industrial protocols like Modbus. So what we wanted to do there was to give you a way to build those applications at the edge without having to write the same Lambda functions over and over again. And so what we built was a set of 11 connectors that connect to 8 popular AWS services and 3 popular third-party offerings. So we've had things like Kinesis Data Firehose for doing data analytics, IoT Device Defender so that you can secure your devices easily, and the ML inference connectors that I mentioned earlier. We also have Raspberry Pi GPIO and the protocol adapter for Modbus. And if you're using Twilio, Splunk, or ServiceNow's metric base, we provide connectors to all of those applications as well so that you can work with them. We're not done. 11 is not a lot of connectors to start with, I know. But in 2019, we're going to continue to work with our partners to add more of them. We're going to be working with Intel to integrate with our OpenVINO toolkit for machine learning on x86 devices. We'll be working with NVIDIA on their DeepStream SDK if you're using the Jetson platform. That should help you there. And OSI, if you're using an industrial historian from them, we'll be working with them to provide a connector that allows you to use Greengrass to work directly with OSI's offering. And in addition to that, and it's not on this slide, we want to talk a little bit about how we're going to allow you to modify the connectors in case they don't necessarily suit your use case. We'll be adding that capability in 2019 as well. And finally, if you want to build your own connectors, then you should be able to. We know that the customer use cases we'll see, we can't know everything. You guys are the true source of truth about that. So we want you to be able to build your own connectors, and we'll provide that capacity in 2019 as well. So that's the overview. How does it work? Luckily, it's pretty straightforward, and I only really need one slide to explain that. You go into Greengrass. In the console, you'll see a new section called Connectors. When you look at that section, you'll see a list of all the available connectors that you can install. You can click one of them, hit Next. It'll take you to a configuration screen where you'll configure the connector by filling out some parameters without writing any code, attach that to a Greengrass group, and deploy it. So let's look at a couple of examples really quickly just to give you an idea of what that might look like. So Amazon SNS. I've mentioned this a couple of times now. It's pretty straightforward to configure this. All you have to do is go into SNS and create a new topic. Once you've created that new topic, get the ARN for that topic, come back to Greengrass, try to install this connector, and when it asks you for the ARN, paste it in. When you deploy it to the group, it creates an MQTT topic of its own, and you can talk to that connector directly via MQTT. Anything you send to that topic will be emitted to the SNS topic. We'll send you a notification. You can do all of that without writing any code at all. But let's say, for example, you don't use SNS. You use Twilio for notifications. OK, that's fine. You can use Twilio as well. We have a connector for that. So it's much the same configuration experience that you would have using SNS, just a few extra steps. So you're going to have to add a secret, which would be your auth token for Twilio, to Secrets Manager. And then once you've added it to Secrets Manager, it's a configurable parameter here. You'll attach that to this particular connector, then specify the phone number and account SID for the Twilio account you're using, and deploy. And then it creates an MQTT topic as well. And sending a message to it on that MQTT topic sends you a notification via Twilio. So that's it. It's straightforward. You just configure and install. You can do it via the console or the API or CLI. And they're all available today for you to try out. So we'll talk a little bit about enhanced security now. I mentioned before that we are extending Secrets Manager to the edge on Greengrass. And so we've got what we call AWS IoT Greengrass Secrets Manager. Now, it manifests itself in a fairly simple way. If you're already using AWS Secrets Manager to maintain or manage your secrets, passwords, keys, credentials, configurations, endpoints, things like that, those secrets that you're managing will just show up as available resources inside Greengrass that you can attach to a group. Lambdas and connectors can both use these secret type resources, and once they're deployed, they're encrypted in transit and at rest. You can also use this in conjunction with a hardware secure element to keep it encrypted using your own hardware. So how does that actually work? Well, like I said, it's pretty straightforward. You go into the console, open up the resources pane, a new resource type secret is available. It'll ask you which secret you want to attach. You attach it, deploy, and it's now available for use by Lambdas and connectors. So that's the first part of security, and we've covered a little bit about the simplified deployments. Now to talk about some of the other security features we're adding in 1.7, I want to invite Tatiana Cook to the stage to tell you about them. Thanks.
Great, and thanks to Scott for providing an overview of a lot of the capabilities that AWS Greengrass allows you to bring from the cloud to your edge device. Of course, when you do that, you probably have questions about how Greengrass can also ensure the security of whatever IoT edge use case you have. So I'll talk first about our existing security model, and then a little bit about the hardware security integration feature that we just announced that will help make your security architecture at the edge even more secure. Greengrass now provides several tools that allow you to keep the messages and data that you're capturing at the edge private and inaccessible to any rogue agents who might want to interfere with it. We provide Mqtt messaging between the core and the cloud that uses TLS encryption. So a private public key pair is provided to your Greengrass core device that it uses to encrypt and decrypt messages. We also use IAM roles in the cloud, identity and access management roles, to make sure that when you do connect to the cloud, your Greengrass core device only has access to the lambdas and resources in the cloud that you want to give it access to. As part of this, our customers use certificates both on their Greengrass core device and on devices at the edge. So this capability is great because it not only provides protection for information that you're sending between your Greengrass core running locally in the cloud, but also between the Greengrass core and any edge devices that you're connecting with. So even in an offline environment where you don't have a connection between the core and the cloud, the messages sent between your core and local edge devices are kept secure, and the X509 certificates that you have present on the core and edge device are used for authentication to make sure that when you're establishing connections, each device is identified and authorized correctly. However, we also hear from many customers that they want to have a Greengrass core device that's running on the edge in a physically unsecured location. For example, they might want to put a Greengrass core device on a smart car that's free and driving around in the world, and you would have different customers using the car, but you want to have some sort of gateway running there locally with Greengrass on it. You might want to install a smart HVAC system in an office building, a hospital, or another location. And while you put your Greengrass gateway device in a closet, a lot of different people who are running around at that location might be able to get access to it. Finally, you could want to do image processing at the edge. For example, at a large conference like this one, where you have more than 50,000 people present. And while you may have great security in place, it can be difficult to guarantee that no one will be able to access physical hardware at the edge and interfere with that in some way. So I'll talk more specifically about how Greengrass hardware security integration is helping customers with two of these use cases. What we've done is introduce an integration using the PKCS11 API interface that allows the Greengrass core to make calls down to a hardware secure element designed by one of our several launch partners. This secure element is tamper-proof, so that means that if you have someone who's trying to interfere with the element and access information on it, it will prevent that information from being shared and ensure that if you have a private key that's stored on that secure element, even if someone has physical access to the device and can get into the file system, they can't access the private key that's being used for encryption and decryption itself. This is great because it works with many different kinds of secure element hardware, and I'll dig into that a little bit later. But for you to take advantage of this, if you already have something like an Intel TPM 2.0, a ZIM key that you might be using with your Raspberry Pi, by deploying a firmware update, you'll be able to make calls down to a private key that is generated and stored on that element, so it never has to leave that element's environment. As I was saying earlier, building automation for HVAC systems brings many risks, and some of you may know that the source of the target data security breach was actually an HVAC system. So in many cases, whether that's for a building where a lot of people are moving around, or in this illustration, a hospital, there are several different points of entry that could put your entire system at risk if you're using IoT. There's spoofing, where you might want to mimic the identity of a valid device that is allowed to make connections to your network. Man-in-the-middle attacks, where information is intercepted and manipulated in some way. Or denial of service attacks, where you overload your cloud system by sending a very high volume of traffic. Greengrass is great because as you build out your IoT use case, our team has developed features that help mitigate the risks associated with each of these types of attacks. Specifically, with hardware security integration, we use hardware root of trust identity for Greengrass Core devices by integrating with those secure elements. And that means that even if someone gains physical control of your gateway device, they can't access a private key in the file system because that private key has been generated and is only accessible in the secure element itself. For the man-in-the-middle attacks, using transport layer security for communication between the core and the cloud means that even if somebody can intercept a message, it's encrypted in such a way that they won't be able to access information being sent. Finally, for denial of service, as I mentioned earlier, only registered devices can connect to the Greengrass IoT Core. So only devices that you've given access to and that have the right certificate present are able to establish that connection. I'll now unpack a use case that will be salient for many of you. I have gone back and forth between the Venetian and the Aria so many times over the course of this week. And every time I go to leave and I'm running a little bit late for a meeting, don't tell my boss, I have to decide whether I'm going to power walk down the strip or grab one of the shuttles. And this new transportation service was introduced last year at AWS. So coming into this year, we knew that it was really important for us to be able to tell attendees how long a shuttle might take. And we started talking with the protective services team because they were interested in introducing a feature that would allow customers to know how long it would take for a shuttle to get from point A to point B. One of the things that we're really excited about as a team is that by working with protective services, we gave them access to our hardware security integration capability to help make sure that information they were capturing to inform their shuttle information, their shuttle time projections, stayed secure. The way their team is doing this is by measuring shuttle queues. So many of you might have kind of walked down the arrow paths as you were getting onto shuttles at reInvent. And part of the reason that we had that physical infrastructure in place was to guide you such that we could count how many people were entering and exiting shuttle lines. And combining that information with how long it was taking buses to get from A to B, we were able to accurately predict how long your transportation might take. Now, there are a few things that come with that. First of all, we wanted to make sure that we weren't saving the beautiful shots of the back of your head we were capturing for privacy reasons and because we didn't necessarily need to store all of that information. So the edge cameras themselves were actually doing some processing and just providing in and out data. That in and out data was streamed to a logic supply box that was running Greengrass. And that logic supply box was hardware that this team had already had that had an Intel TPM 2.0 trusted platform module secure element. We worked with their team to integrate with their Greengrass at the edge to make sure that they could use the TPM equipment that they already had for the private storage of that key. Once that private key was stored in the secure element, their team felt confident about sending that encrypted data from those edge supply logic supply boxes, which are really small, so it would be easy for someone to grab and put in their pocket, up to the IoT core in the cloud and to an API gateway. That gateway was then used to generate the times that you saw in your app. We're really excited about this use case because we think that it highlights a lot of the great capabilities of Greengrass. You can aggregate information at the edge and pre-process that. For example, understanding how many people are moving in and out of lines, then take advantage of security capabilities our team has already built to get that information safely up to the cloud to drive applications that deliver real value for customers. So I was able to get here in time for this session because I knew how long the shuttle would take and felt confident taking that method of transportation. Now that you're amped up about hardware security integration, I'll tell you a little bit about how to get started. First of all, you can work with many of the secure element vendors that we've integrated with and follow their directions for generating a private key on your secure element. Like I said earlier, this works with existing equipment that you have already. So if you're sitting out there thinking about secure elements you have sitting in the field, maybe unused on your Greengrass gateway device, please generate your private key using their protocols. And then update your AWS IoT Greengrass configurations. This is a fairly simple change to your config.json file to point towards the private key in the secure element rather than in the file system where you might have pointed towards it in the past. You'll need to make sure that your certificates are authenticated correctly, but once this is in place, we've taken care of all of the API integration, so it's easy to communicate down and make calls to access that private key. Finally, as Scott mentioned, we have an integration with our new Greengrass Secrets Manager capability. I'm sure that once you bring your secrets down to the edge, for use in other applications and connectors, you'll want to make sure that those are as secure as possible. And we support PKCS11, encryption and decryption of those secrets, again, taking advantage of the secure element present on your hardware. So we've done the heavy lifting to make sure that you're able to use the best hardware possible for this capability. We're excited to be launching this in collaboration with a series of partners who we've worked with to have the integration available already. So we're glad to say that we worked with Intel, Logic Supply, Microchip, Infineon, NXP, ST Microelectronics, Soracom, Vitro, Yubico, and Zimbit. So if you have equipment from any of these vendors, they're all posting information about how their side of the integration works. And that is going to be accessible through our new partner device catalog. So if you are excited to add more security to your existing IoT architecture, you can search for HSI and find a series of qualified devices that our team has worked on to ensure that they'll work correctly at the edge. Each of these device pages will also include information about what the vendors recommend in terms of this security integration piece, how to generate private keys. A bunch of partners have engineers who are writing blog posts about their experience going through the integration, so there's a lot of documentation that's already available about this. Of course, we're always interested in working with new partners. So if you're a partner in the audience and you're hearing about this and think that you'd like to do an integration as well, we encourage you to check out our AWS IoT Device Tester tooling. If you're a customer and you also want to start testing your devices to figure out if they're Greengrass compatible, this tool is publicly available. And again, there's documentation that will help you work through that process. There's a lot packed in here, so happy to answer questions. And please do reach out if you're a partner and you'd like to get your hardware qualified for this new capability. Great. So we've talked about a lot so far, and I'll end with a quick note about greater flexibility that we're introducing for Greengrass today. Since we developed Greengrass, we've heard from customers who want to take advantage of Greengrass in many different kinds of environments. For example, they might be interested in running Greengrass in a Docker container. They might want to run Greengrass in an environment where there are fewer dependencies and they don't have to make kernel-level changes to get Greengrass up and running. Finally, customers might be running on devices where they want access to different kinds of local resources, like Bluetooth Low Energy devices or USB devices that don't have a fixed file path. We're excited to announce today that we're making it much easier for you to get up and started with Greengrass by introducing new permission and isolation configurations, so that if you have a bunch of applications running side by side in Docker containers on whatever on-premise device you're using, you can simply deploy Greengrass to run alongside of all of those in its own Docker container. We're making this possible by introducing 2 new modes that you can use to run your Greengrass software. Today, AWS IoT Greengrass provides the benefits of security and isolation that come with running each Greengrass Lambda in its own container. And customers really like this. It makes it easy for you to run a lot of Lambdas side by side, develop those independently. You can set memory limits at a per Lambda level so that you're not consuming too many resources. As Scott mentioned, we also have device resource access through device resources that you can access through local resource access. And we solve a lot of the difficulties of communicating from an application inside a containerized environment to a local resource with that capability. However, we're all about giving customers the flexibility to try different things. So we have 2 new modes you can test. The first one is the ability to run Greengrass as an OS process, so that Lambdas and the Greengrass group itself, where you have underlying system Lambdas doing some functions, no longer have isolation. That means that they can directly access device resources and your underlying operating system and hardware. So this is what allows you to run Greengrass inside of a Docker container or another containerized environment. We've kind of stripped that layer out, and you can choose whether you want to bring that to the edge. The second option you'll have is what we call hybrid mode, where you can mix isolated Lambdas and Lambdas running as OS processes. This is great because maybe for the vast majority of the functions that you want to pull down to the edge, you want to keep those isolated and you want to have the benefits of the Greengrass provided containerized environment. However, for 1 or 2 of your Lambdas, you might want to communicate with a local BLE device or have some other capability that requires you to access underlying resources that you can't get to with local resource access. So we're excited to give you the per Lambda configuration to choose whether or not you want container isolation for your Lambdas. This is easy to do. You can flip this capability on and off at the group level, and here I've shown a shot of where you're able to do that in the console. You can also go in and have the granularity on a per Lambda level to make a decision about what kind of environment you want your Lambdas to run in. We've also introduced new permission capabilities. So for those of you who are familiar with Greengrass prior to this week, we provided one user and group ID that you could run with, GGC user and GGC group. Now, on a per Lambda basis, you can choose to run Lambdas with different permissions. Perhaps you have a function that you want to run with more restrictive permissions, or you want to give one or two different functions the ability to run as root. Be careful with this one, but we also trust you as very intelligent customers, so kind of use with caution. But what's great about this is, again, you're going to have more granular control over the way that your different Lambda functions on the edge interact with each other and the underlying operating system and hardware that you have in place. As a quick note, actually, going back to this slide, one other note, here we don't currently support machine learning and connectors to run in no container mode, so just be aware of that when you're getting started, but that's something that we're going to be working on in 2019. Finally, and to end on like a high energy note, hopefully a lot of people who've tried Greengrass will be excited about this. Because you can run Greengrass inside of Docker, you can now run Greengrass in a Docker container on Mac OS X or on Windows 10. So our team's really excited about this. We think it's going to make it way easier for you to get started with Greengrass. And as part of this, we have released a Greengrass Docker image and Docker file with information about how to create your own Docker image on our page. So if you have questions about that, please let me know. But we're excited to see what people can do with that. Really, really easy to get from start to having Greengrass running a container now. I'll quickly recap what we've talked about for this specific release, and then Scott and I will hopefully get some great questions from you guys about Greengrass's existing and new capabilities. To get started with simplified deployments using Greengrass connectors, you can try it from the console. So for the 11 connectors that Scott mentioned, we have documentation available, and it's really easy with no coding required to get these connectors running in your Greengrass core environment. We have these enhanced security features. If you want to use Secrets Manager, you can attach secrets to your Greengrass group as a resource from the console before deploying. And we encourage you to check out our device qualification portal to learn more about hardware where you can introduce root of trust security for Greengrass. Finally, given this new per Lambda isolation and permission capability, we would love for you to try our Docker file. We have documentation about how to get started with that, so test it out, let us know what you think, and hopefully a lot of you will be running Greengrass in all different kinds of environment, whether that's your laptop or a Raspberry Pi or a huge server you have on the edge to take advantage of the capabilities that we provide. Thank you all for your time and attention. We know that it's been a long week, and many of you might be thinking about lunch, but we appreciate you coming to learn more about Greengrass and are happy to answer any questions that you have. So please go to the mics and shoot.